For years, General Motors' 6.2L V8 was marketed as one of the most powerful and refined engines ever installed in a full-size pickup or SUV. Found in vehicles like the Chevrolet Silverado 1500, GMC Sierra 1500, Tahoe, Suburban, Yukon, Escalade, and high-performance trims such as Trail Boss, AT4, and Denali, the 6.2L promised big power, smooth driving, and premium reliability. But behind that promise, a serious issue has quietly followed thousands of owners: 6.2L lifter failure. For a long time, GM avoided using strong language. Dealers called it normal noise. Service departments blamed oil quality, driving habits, or delayed maintenance. Owners were told the problem was rare. Now that tone has changed. While GM has not held a dramatic press conference saying, "We failed," internal service bulletins, warranty pattern changes, revised part numbers, and engineering updates strongly suggest one thing: GM has effectively admitted the 6.2L lifter failure is real, widespread, and design-related. The bigger question now is this: is the rumored 2027 fix the real solution, or just another Band-Aid? Let's break it all down clearly, honestly, and with real expert insight. What is the GM 6.2L lifter failure? At the center of the problem is GM's active fuel management, AFM, and later dynamic fuel management, DFM systems. These systems are designed to shut down cylinders during light driving to improve fuel economy. On paper, it's brilliant. In the real world, it has been disastrous for many owners. The 6.2L uses collapsible hydraulic lifters that engage and disengage constantly as cylinders turn on and off. Over time, these lifters can collapse internally, stick in the bore, lose oil pressure, and fail to re-engage properly. When that happens, the camshaft continues rotating, but the lifter no longer follows the cam lobe correctly. This leads to metal-on-metal contact, rapid wear, and, in many cases, catastrophic engine damage. Once a lifter fails, the engine often develops loud ticking or knocking, misfires, check engine lights, loss of power, and complete engine failure if driven too long. In severe cases, the camshaft is destroyed. Metal debris circulates through the oiling system, and the entire engine must be replaced. Why the 6.2L is hit harder than other GM V8s? Experts point out that while lifter failures also affect GM's 5.3L and 6.0L engines, the 6.2L is especially vulnerable for several reasons. First, the 6.2L produces significantly more torque. That higher load puts more stress on lifters during cylinder deactivation and reactivation cycles. Second, many 6.2L engines are installed in heavier vehicles or performance trims. Trucks like the Sierra AT4, Silverado Trail Boss, and Escalade are often driven harder, tow more, and see more aggressive throttle input. Third, tighter tolerances in modern engines mean less margin for oil pressure variation. Any momentary oil starvation, even during cold starts, can be enough to trigger lifter damage over time, according to former GM powertrain engineers and independent engine builders. The problem is not owner abuse. It's a design sensitivity issue, the role of oil in cold starts. GM is often pointed to oil quality as a contributing factor, and while oil matters, experts agree it is not the root cause. Cold starts are especially dangerous for the 6.2L lifter system. During startup, oil pressure takes a moment to stabilize. Lifters may not fill evenly. AFM and DFM components are under stress. Repeated short trips make things worse. The engine never reaches full operating temperature. Moisture builds up in the oil, and lifter internals degrade faster. But here's the key point: a properly designed lifter system should tolerate normal driving behavior. When engines fail at 30,000, 40,000, or 60,000 miles under normal use, the responsibility shifts away from the owner and back to engineering. Lawsuits and warranty patterns tell the real story. One of the strongest signs that GM has effectively admitted the 6.2L lifter failure problem comes from legal pressure. Multiple class action lawsuits have been filed alleging defective lifter design, known failure patterns, insufficient warnings to customers, and costly repairs outside warranty. At the same time, GM quietly began approving more out-of-warranty goodwill repairs, especially for vehicles with full service records. Dealers also report internal guidance to inspect lifters more aggressively. replace camshafts during lifter repairs, and use updated part numbers. This is not how manufacturers behave when a problem is rare. What has GM changed so far? GM has already made several behind-the-scenes changes, even if they haven't marketed them loudly. These include revised lifter designs with improved internal tolerances, updated camshaft surface treatments, software changes that reduce aggressive cylinder switching, new oil specifications, and updated service recommendations. However, many experts believe these changes reduce the failure rate but do not eliminate the root cause. As long as collapsing lifters are repeatedly cycled on and off, the risk remains. The rumored 2027 fix. What experts are saying. Now we get to the big question. Is the 2027 fix real? Based on supplier leaks, engineering chatter, and industry analysis, the most likely changes coming around the 2027 model year include 1. A redesign of lifter system. GM is rumored to be moving toward a more robust lifter design with stronger internal locking mechanisms, improved oil flow paths, and less reliance on rapid collapse and re-engagement. This would reduce wear during frequent cylinder transitions. 2. Reduce dependence on AFM and DFM. Instead of aggressive cylinder shutoff, GM may rely more on transmission efficiency, mild hybrid assistance, and improved combustion efficiency. This would dramatically reduce lifter stress. 3. Software that prioritizes durability. Engine control logic is expected to limit cylinder deactivation during cold starts, reduce rapid on-off cycling and stop-and-go traffic, and favor full cylinder operation under moderate loads. Experts believe software alone won't fix everything, but combined with hardware changes, it could make a meaningful difference. Will the 2027 fix apply to older engines? This is where owners need to be realistic. Historically, GM does not retroactively redesign engines for older vehicles. That means a true mechanical fix will likely be limited to new engines. Existing owners may only see partial improvements through software updates. Some aftermarket solutions, such as AFM, DFM delete kits, have proven effective when installed correctly, but they come with trade-offs and warranty implications. What mechanics are saying right now. Independent GM specialists are remarkably consistent in their opinions. Most agree on 3 points. 1. The 6. 2L is a strong engine when the lifters survive. 2. Lifter failure is not random. It follows clear patterns. 3. Eliminating or reducing cylinder deactivation greatly improves long-term reliability. Many mechanics privately advise customers that if they plan to keep a 6-2L long-term, addressing the lifter system proactively is smarter than waiting for failure. Is the 6-2L still worth buying? This depends on how long you plan to keep the vehicle. For short-term ownership under warranty, many buyers continue to enjoy the 6-2L with no issues. For long-term ownership beyond 100,000 miles,